So now we're starting section 4.3, and specifically we're going to be looking at what a coterminal angle is and what it means when they refer to something about the terminal side and the unit circle. The first definition I want to go over is what are the angles that we're measuring. So whenever you see something about 45 degrees or 90 degrees, I want you to realize that we're describing the number that is how much we're rotating from the beginning position to the ending position. Our angles in math, we start from pointing to the right and we measure counterclockwise. So if you're looking at this example, the unit circle, we have starting from 0 degrees going to 30, 45, 60, 90, etc., all the way around. So whenever we describe an angle, we're just describing how far you've rotated around. And it'll actually loop around again multiple times, which is what we're going to talk about in just a few moments. So positive angles are the counterclockwise rotations. It is also fairly common to see a negative angle described, and that just means you're showing how far it's rotated clockwise. So if I instead went this same length, instead of going 30 degrees counterclockwise, if I went 30 degrees clockwise, that would be the same as negative 30 degrees. So going backwards does a negative angle. Coterminal angles are angles that have the same terminal side, so they end up pointing in the same direction, but they have different angle measurements. For example, if you look at the unit circle, we actually described this using coterminal angles. We've described pointing straight to the right as both 0 degrees and 360 degrees. And you could continue to do that over and over and over again if you just keep going around the unit circle in either direction. So I could also call that negative 360 if I rotated clockwise once. And then if I went around again, that would be negative 720. Same thing happens with angles like 30 degrees. I can start at 30 degrees, so here's the terminal side, 30 degrees. And then if I went around another whole revolution, that would be 390 degrees. And that would end up pointing in this exact same direction. It would have the same terminal side. So we usually like to write our angles between 0 and 360. And we're going to go over the process for how to rewrite them when they're outside of that range. So angles are coterminal whenever they differ by an integer multiple of 360 or 2 pi radians. What I mean by that is you can add or subtract 360 degrees, or if you're in radians, 2 pi, and it'll give you another angle measurement that has the same terminal side. If your angle is bigger than 360 or smaller than 0, then you will want to add or subtract 360 degrees until you get another way of writing that angle that is between 0 and 360. Or if you're in radian measurements, if your angle is bigger than 2 pi or less than 0, then you would add or subtract 2 pi until you find an angle that is coterminal with the one you were given, but is between 0 and 2 pi. So let's look at an example of this process. So this one says which angle is not coterminal with the others. So just go ahead and pick one to start from, like 200 for example. And if you add 360 degrees to that, you get 560 degrees. If you instead took the 200 and you subtracted 360 degrees, you would get negative 160. So what we're looking at is starting from 200, which is about here, in between the 180 and the 210, if you went one full revolution around, if you added 360, that's one of the measurements we just looked at. If you subtracted 360, it was going around clockwise. So we just found that both 560 and negative 160 are coterminal. So let's repeat that process. So if you start from 200 and you add 360 and then you add 360 again to make a second revolution, you should get 920. But 920 is not the angle that we have listed here. That one's only off by 100. It should be off by 360 one direction or the other. So this one is the angle that is not coterminal with the others because it is not an integer multiple of 360. I can't just say 2 times 360 and add it on, or 3 times 360 and add it on to get the next one. This is the same idea, but it's in radian form instead, which can be a bit more annoying because you have to remember for adding and subtracting fractions that you need a common denominator. So in this particular example, since we're trying to add 2 pi and our denominator is 2, make sure that you remember 2 pi is equal to 4 pi over 2. I'm just getting a common denominator to make it easier to add or subtract. So if you start with negative pi over 2 and you add 4 pi over 2, you get 3 pi over 2. If you start from negative pi over 2 and you subtract 4 pi over 2, you should get negative 5 pi over 2, not negative 3 pi over 2. So this is the one that is not coterminal with the other angles. You can obtain 7 pi by taking the 3 pi and adding 4 pi over 2 again. So this one does not match the others. This is the one that is a different angle altogether. Next, we're going to look at the signs of the trig functions. If you're talking about the sine function, sine is based on the y-coordinate of the unit circle. So if you think about your regular x and y grid, the y-coordinates are positive when you're in the first and second quadrant. So sine is also going to be positive in the first and second quadrant. Cosine is based on the x-coordinate, and x is positive on the right-hand side of your Cartesian plane. So that means it's going to be positive in the first and fourth quadrant. And then the last one is the tangent or cotangent functions. These are based on y divided by x. So you either need both the x and the y coordinate to be positive, which happens in quadrant 1, or you need both of them to be negative, because then a negative divided by a negative is positive. So that happens in the third quadrant. So the two places that tangent and cotangent will be positive are quadrant 1 and quadrant 3. So on the next examples, they're going to either define a range like from 0 to 90 degrees, or they're going to give you a specific angle and a specific function and ask you whether it should be positive or negative according to these rules. So this says state the signs of sine, cosine, and tangent for values of t in the interval from 0 to 90 degrees. So when you're looking at your unit circle, 0 to 90 degrees means they're asking us about this quadrant 1 region, all the angles between 0 and 90, like 30, 45, and 60. So we want to think about quadrant 1, and you can look back at your diagram if you'd like for this. So sine is going to be positive in quadrant 1, cosine is going to be positive, and tangent is going to be positive. The question asked us for those three functions, sine, cosine, and tangent. All three of those are going to be positive. Next, let's look at an example where they give you specific angles they want you to look at and specific trig functions. So sine of 100 degrees. If you check the unit circle, 100 degrees would be in here between 90 and 120. So it's somewhere up here in the second quadrant. And we said sine is based on the y-coordinate, and the y-coordinates up here are positive. So the first answer is going to be positive. We don't know the specific value, but I know that it's positive. Cotangent, 11 pi over 6. So now we've got one in radian form. So instead of focusing on the degree measurements, I'm going to focus on the radian measurements. So the angle we were given is 11 pi over 6. And we actually have that angle listed on our unit circle, so we don't even have to estimate which ones it's between. 11 pi over 6 is down here in the fourth quadrant. So when we're considering our tangent and cotangent functions, we said that's based on the y value divided by the x value. Since one of those is negative and one of those is positive, when you do y divided by x, you're going to end up with a negative answer for cotangent. And the last one is cosine of 4 pi over 3. 4 pi over 3 is also on our unit circle. And since this is the cosine function, cosine cares about the x-coordinate. Well, if you look at the x-coordinate for this angle, the x-coordinate is negative, which means cosine is negative. They didn't ask us to evaluate the specific values, they just wanted us to say positive or negative. Now we're going to look at what happens if you are given a coordinate and then you are asked to evaluate the trig functions based on that. The first thing you'll want to do is draw a right triangle with that given coordinate. The x value in the ordered pair is going to be the base of your triangle. So when you draw your right triangle, that was terrible. The x value would be the base of the triangle, and the y value would be the height of the triangle. So the signs, you will have some positives and negatives on this. Those don't really make sense in terms of saying I have like a -3 distance, but they will be useful in determining the direction that you go for x and y. For example, maybe if your x value was negative on the triangle, then I would have drawn it going to the left and up, and then back over diagonally. So the negatives will be helpful in evaluating the trig functions, and they'll help you to identify which quadrant you're dealing with. You will have to find the length of the hypotenuse using the Pythagorean theorem, because you're only getting x and y from the ordered pair. So the third side of the triangle, which you will usually need to use to evaluate things like sine and cosine, since those are opposite over hypotenuse and adjacent over hypotenuse, that you will usually need to identify by using the Pythagorean theorem. Here's an example of one. They've given us the coordinate -3, 4. They've told us that it's on the terminal side of theta. Remember, that just means when you're looking at your unit circle, it's the line that's pointing to that angle. So if I have an x value going -3, I would start from the origin and go left 3, and then I would go up 4 for my triangle. So I'm going left a distance of 3, up a distance of 4, and then you probably recognize if this is a right triangle, that means this must be one of those popular 3, 4, 5 triangles we've used a few times in the class. So even without using Pythagorean theorem, you might know that one at this point. So now I have my right triangle. It's a 3, 4, 5, and when I'm going to evaluate my functions, I'm going to have sine of theta is equal to, here's the angle I'm using for reference, is equal to opposite over hypotenuse. So in this case, this is going to be 4 over 5. Now before I do cosine, I want to point out that, like I said with the signs of the numbers they gave us, it doesn't make sense to call this a length of -3, but that's actually what I want to do just to make it easier to evaluate the cosine function. Because we're actually talking about a triangle that's going to the left on the coordinate system. So for cosine adjacent over hypotenuse, I'm actually going to end up with -3 over +5. Now your hypotenuse will always be positive, but I'm just encouraging you to actually use the sign of the x and the y coordinates on the base and the height of the triangle, even though it does not make sense to say that this length is -3 long. So cosine is -3/5 because we're dealing with an angle that's in the second quadrant. And then tangent of theta which is equal to y divided by x, or opposite over adjacent, will end up being -4/3. They want all 6 trig functions, so for the reciprocal ones, all you have to do is take the reciprocal of the numbers we already evaluated. So cosecant, when you flip 4 over 5 upside down, will be 5 over 4. Secant, when you flip it upside down, will be -5 over 3. And then the last one is cotangent. If you flip that, you'll get -3 over 4. Remember, the easiest way to try to pair which functions are reciprocals, I like to recognize that one of the ones that starts with an S is paired with the one that starts with a C, and then vice versa. The one that starts with a C is paired with the one that starts with an S. Tangent and cotangent people usually do pretty well with. So that's all for the notes today on the unit circle. We'll continue to explore the patterns and the systems for it over the next couple weeks. That's all for the notes. Thank you.